The objective today is to describe what the Intel manual says about status flags. So we're on page 78. It says that the status flags, bits 0, 2, 4, 6, 7, and 11 of the E flags register, indicates the results of arithmetic instructions. So if we look at these numbers here and go up, 0, 2, so here 0 is, if we follow along it says carry flag. So basically all the S's right here is what these paragraphs are about. So arithmetic instructions are pretty straightforward. You got add, subtract, multiply, and divide. By the way, when computers multiply and divide, it's really interesting. All you have to do if you're multiplying by 2 is you shift the bits over. It's called a left shift. And then if you're dividing by 2, you just right shift by 1. And same with if you're dividing by 4, then you would right shift twice, and you just keep following that pattern. But here it says that the status flag functions are, and so it's going to tell us all the functions. Your carry flag. This is set if an arithmetic operation generates a carry or a borrow. So borrow for subtraction, right? So this flag is generated out of the most significant bit of the result, else it's cleared. This flag indicates an overflow condition for an unsigned integer. Unsigned meaning a positive number. Or at least that's how positive numbers are treated in arithmetic. And apparently, this is also used in multiple precision arithmetic. Not really sure what this is a reference to. So quick question, what does the carry flag do? Okay, and then I just rapid fire rattled off the rest of those because this is a pretty straightforward section here. So parity, this is set if the least significant byte of the result contains an even number of bits. So 1 equals even, 0 would be an odd. So think of parity as like even or odd. And you could do a little system check to make sure this flag matches with what you were expecting it to. Now we have something called the auxiliary flag, and this one is a little confusing to me. It says it is set if an arithmetic operation generates a carry or a borrow out of a bit 3 of the result, or else it's cleared. So what is that? A carry or borrow out of bit 3 of the result? That's an auxiliary carry flag, and this is apparently used in binary coded decimal arithmetic. So what is that? It looks like we might find BCD as an acronym out there. Now I promised in these videos I'll just stick with the manual instead of going on field trips to go find that out. So let's keep it moving here. It says the 0 flag is set if the result is 0. Very easy. The sign flag set equal to the most significant bit of the result, which is the sign bit of a signed integer. So most significant bit meaning if I go down here and create a byte, okay, there's 8 bits right here. If this one right here is a 1, then that means you're looking at a negative number. So if I change this to a 1, this number is actually -2. All because that bit, the most significant bit right there, is a 1. So really straightforward. Now there's sort of, I wrote here, 2 overflow flags, but this overflow flag is set if the integer result is too large a positive number or too small a negative number, and that's when you're excluding the sign bit, to fit in the destination operand. So if you do something to a number and you want to fit it into the destination address that is too small for it, you're going to get this flag. Now this flag indicates an overflow condition for signed integer using 2's complement arithmetic. So kind of going right back to what I said here. If there's a 1 right here, and the rest of these are supposed to all be 1s plus something more, making it a very, very small number, because we're talking negative values here. If that's the case, then the overflow flag will trigger. And I should remind you here, we're not talking about one single bit. If we're talking about a 32-bit operating system, we're talking about a number that's like really long, right? So keep that in mind. To overflow, you need a pretty big number or a very, very small number. In a 64-bit system, that seems really difficult to do, but of course it's a security vulnerability if you can get the computer to do that. When will an overflow flag trigger? And you can go into as much detail right there as you'd like. And now I did add this question. Is this EAX we're talking about? Is the register that's holding the result the number that the flag, all these flags are actually looking at? If so, that makes quite a bit of sense. Those things are directly connected then. Now I start this next section off with a joke. I'm saying the carry flag is like super popular. That's because of these status flags, only the carry flag can be modified directly using the STC, CLC, and CMC instructions. So I assume this is like store carry or clear the carry or something else. Also, the bit instructions, so those we talked about earlier, I assume this does not stand for Bitcoin. Those bit instructions copy a specified bit into the carry flag. So when we learn more about those instructions, I'm sure we'll understand its relationship to the carry flag better. And that's a good question number 7 to add. What do status flags tell us? Alright, so the status flags allow a single arithmetic operation to produce results for 3 different data types. You got your unsigned integers, signed integers, and BCD integers. If the result of an arithmetic operation is treated as an unsigned integer, the CF flag indicates an out-of-range condition. Alright, so what is an out-of-range condition? So an out-of-range condition is the result of an arithmetic operation that's working with an unsigned integer. So an out-of-range condition is when there's a positive integer that's the result of an arithmetic operation. So that's really confusing. Like, why is it out of range? Because the carry flag needed to do some carrying or borrowing on a positive number? I'd imagine a simple concept like that would not be called like out of range. Out of range has like this maybe negative connotation. Unless we're talking about the bit is out of range, so it needed to have been carried to show us a larger number. Yeah, either way, if treated as a signed integer using, of course, 2's complement, there's a lot of videos on YouTube talking about that if you need to better understand 2's complement. But if we're talking about a signed integer, a negative number, the OF flag indicates a carry or borrow. So that's the overflow flag. Alright, so overflow flag for negative numbers, CF or regular carry flag for positive. Alright, so really good question there. Apparently, if treated as a BCD digit, the auxiliary flag indicates a carry or borrow, so I almost just want to do that as a note. BCD uses the AF flag. And then the SF flag, what's SF stand for? Oh, sign flag, so the SF flag. Alright, that's real straightforward. Now the ZF, that 0 flag, indicates either a signed or unsigned 0. That's really weird. Can you have a negative 0? I mean, that's the reason we don't use 1's complement, actually. Well, when performing multiple precision arithmetic on integers, the CF flag is used in conjunction with the add. Add with carry, that is, so ADC, and subtract with borrow instructions to propagate a carry or borrow from one computation to the next. So multiple precision arithmetic takes on these extra instructions. And my question is a just asking question. There you go. When do programmers use multiple precision? Now the condition instructions JCC, that is jump on conditional code, and then the instruction set CC, that's byte set on a condition code. And then you got loop CC and cmove CC. These instructions use one or more of the status flags as condition codes and test them for branch, set byte, or end loop conditions. So my question, which instructions relate to the status flags? And you would say JCC, set CC, loop CC, move CC, and then you'll be getting a nice little sneak peek at some assembly language there. Let's finish with this direction flag just because it's a real short section, and that way the next video I'll go all over system flags in IOPL field. So the direction flag, DF located in bit 10 of the E flags register, controls string instructions, so there those instructions are. Setting the DF flag causes the string instructions to auto-decrement 2 process strings from high addresses to low addresses. Clearing the DF flag causes the string instructions to auto-increment. So I guess that is process strings from low addresses to high addresses. And then the STD and COD instructions set and clear the DF flag respectively. So just remember the direction flag is all about strings, while we had just spent a significant amount of time looking at the status flags, which relate to numbers, aka integers. So thanks for watching, and I will see you next time when we cover system flags.